All right, today we're going to be taking a deep dive into the world of open source AI.
Okay.
Specifically, we're going to be looking at this research paper on DeepSeek-V3, this massive language model that's making some pretty big waves. And right out of the gate, it boasts a pretty impressive 671 billion parameters.
Yeah, it's pretty massive. But the scale, I think what's most impressive is that they managed to achieve this scale while remaining very efficient.
Yeah.
And I think a big part of that is this mixture of experts or MOE approach.
Oh, yeah, MOE.
Yeah.
Now, for those of us who aren't super familiar with that, could you maybe break that down a little bit?
Yeah, so instead of having all 671 billion parameters active at the same time, they essentially created this system where only a subset of those parameters are actually engaged for a given task.
Oh, that's pretty cool.
So only about 37 billion parameters are active at a time.
Okay, so they basically created like a system where only the most relevant sort of experts are chiming in.
Exactly.
For a given task at any moment.
Yep.
And that really helps, I imagine, avoid that computational bottleneck you'd normally have with such a massive model.
Yeah. And they also introduced this innovative auxiliary loss-free load balancing strategy.
Okay.
Which essentially, it's kind of like a traffic system within the model.
Okay.
Making sure that no single expert gets overwhelmed.
Right.
And that the performance remains really strong.
Yeah. And that's a huge point because I know a lot of times these large language models, they struggle to kind of find that balance between, maintaining that kind of balance and also maintaining performance.
Right.
And, speaking of kind of thinking outside the box, another thing that really caught my eye was this multi-token prediction, or MTP.
Yeah.
So could you talk a little bit about how predicting multiple words at once leads to greater efficiency?
Yeah. So imagine like if you were reading a book.
Right.
And you could kind of anticipate not just the next word, but the next few words or even the next sentence. That's essentially what DeepSeek-V3 is doing with multi-token prediction. It's allowing it to process more information at each step.
So it's like giving the model a little glimpse into the future.
Yeah, exactly.
And that must really speed up the learning process.
It does. It makes the training much more efficient. And, potentially it could lead to much faster text generation down the road, too.
Yeah, that was something that the paper alluded to as well.
Right.
And now I think it'd be great to sort of transition and talk a little bit about the task of actually training a model this massive.
Yeah.
I mean, you mentioned earlier 2,048 NVIDIA H800 GPUs.
Right.
That alone kind of paints a picture.
Yeah, it's a massive endeavor.
Of the scale of this project.
Right.
But, I think one of the things that they highlight is really their approach to optimizing the communication between these GPUs.
That's one of the most impressive things, I think. So they've actually developed these specialized communication kernels that essentially allow the GPUs to overlap communication and computation.
Oh, wow.
So you can have one GPU crunching numbers while another one is already fetching the next batch of data.
So it's all kind of happening very seamlessly and simultaneously.
Yeah, it's very efficient.
So this tight integration of the hardware and software is really what allowed them to achieve this remarkably low training cost of only about $5.576 million.
Yeah, which, it might sound like a lot, but in the world of large language models, that's actually incredibly cost effective.
Yeah. And that's a huge game changer, I think, for a lot of researchers and developers who don't have access to those vast resources that, some of these big tech companies do.
Yeah, it really opens up the playing field for innovation and research.
And so this sort of brings us, I guess, to the question of performance.
Yeah.
How did DeepSeek-V3 actually stack up against other models on some of these benchmarks?
Yeah, so they evaluated on a really wide range of tasks.
Right.
And their results were very impressive.
Yeah. And I know that they looked at a couple of different versions of DeepSeek-V3.
Right.
So how did the base version DeepSeek-V3 base perform?
Yeah. DeepSeek-V3 base consistently outperformed other open source models, especially in tasks that require like a lot of logical reasoning.
Right.
So things like coding and math.
And then they also had this sort of chat-tuned version.
Right.
So how did that stack up?
Yeah, so the chat-tuned version actually went head-to-head with some of the leading closed-source models.
Wow.
So like models like GPT-4 and Claude.
Oh, that's exciting.
And it actually either rivaled or even surpassed them on several of these benchmarks.
Wow.
Which is really remarkable.
So not just a contender in the open source arena, but really kind of a legitimate rival to some of the top models in the field.
Absolutely.
Well, I think that's a great place for us to maybe take a little pause.
Okay.
And then the next segment, we can kind of dive a little bit deeper.
Sounds good.
Into those post-training enhancements.
Right.
And how they really kind of shaped DeepSeek-V3 into the powerful tool that it is.
Okay, great. Welcome back. All right, so let's pick up where we left off and really dive into those post-training enhancements that really kind of fine-tune DeepSeek-V3's capabilities.
Yeah, they really sort of put it through a specialized training regimen, you could say.
Yeah, exactly.
With supervised fine-tuning or SFT and reinforcement learning or RL.
Yep, and the paper goes into some pretty interesting details about the data they used for both SFT and RL.
Yeah, and there was this one detail that really stood out to me, which was this concept of model lineage.
Yeah, it's a fascinating idea.
Can you talk a little bit more about that?
Yeah, so they actually used a mix of data.
Okay.
So they used human annotated data.
Right.
But they also incorporated data that was generated by previous models. Oh, interesting.
Including DeepSeek-V3's predecessor, DeepSeek-R1.
So they're sort of passing down the knowledge from one generation to the next.
It's kind of like, building on the shoulders of giants.
Yeah, exactly.
And so for the data that was focused on things like reasoning, like math problems, coding challenges.
Right.
They found that the data generated by DeepSeek-R1 was actually highly accurate, but it was often a little bit too verbose and complex.
So even AI-generated data needs a little bit of editing.
Yeah, exactly.
Yeah.
So they had to refine the formatting, make sure the responses were concise, but still retain those key reasoning steps.
Right. So it's kind of a delicate balance between accuracy and clarity, I guess.
Exactly.
Now, for those tasks that didn't really have a clear right or wrong answer, things like creative writing or role-playing, they actually relied on human annotators.
Yeah, you still need that human judgment to ensure that the training data was high quality and appropriate.
Exactly.
Now, moving on to the reinforcement learning phase.
Right.
You mentioned that they used a combination of rule-based and model-based reward systems.
Right.
So can you maybe break those down a little bit?
Yeah, so a rule-based reward system is fairly straightforward.
Okay.
If the task has like a clear objective measure, like, solving a math problem or debugging code, you can just use predefined rules to assess the performance.
Gotcha. So for more open-ended tasks, you would use a model-based system.
Exactly.
So how does that work exactly?
Yeah, so for tasks like creative writing, where there isn't a single correct answer, you need this model-based reward system. Right. So essentially, you train a separate reward model to evaluate the quality and coherence of the responses.
So it's almost like having a judge at a writing competition.
Yeah, that's a great analogy.
And I think one of the really key things here is that they provided not just the final reward, but also that chain of thought that led to that reward.
That's key for ensuring that the model is actually learning.
Right. And not just trying to game the system.
Exactly. Yeah.
So with all of these sophisticated fine-tuning techniques in place, how did DeepSeek-V3 actually perform on these benchmarks?
Yeah. So across the board, DeepSeek-V3 demonstrated very impressive capabilities. DeepSeek-V3 the base model, consistently outperformed other open source models, especially in those coding and math tasks.
And then what about the chat-tuned version?
Yeah, so the chat-tuned version of DeepSeek-V3 actually went head-to-head with models like GPT-4 and Claude.
Wow.
And the results were really quite remarkable. It actually rivaled or even surpassed them on several of these benchmarks.
So it really is kind of a top contender.
Yeah, it's up there with
in the field.
Yeah, absolutely.
I know you mentioned this arena hard benchmark.
Yeah.
Which is particularly challenging.
Yeah, it focuses on these really complex real-world tasks involving coding debugging and deep language understanding.
Right, so it's not just following instructions. It's really having to solve problems.
It's problem solving and reasoning.
And DeepSeek-V3 achieved a pretty impressive win rate.
Yeah, over 85%.
Against the baseline GPT-4 model.
Right, which is a substantial margin.
Yeah, and then on the AlpaCaval 2.0 benchmark, which focuses on writing quality and handling nuanced language, it, again, outperformed.
Yeah, it did very well.
Both closed source and open source models.
Yeah, it was really quite versatile.
And so this is what I think makes this research so exciting.
Yeah.
DeepSeek-V3 is really pushing boundaries on multiple fronts.
Absolutely.
It's achieving this incredible scale, efficiency, and performance.
Yeah.
And, on top of its impressive capabilities as a language model,
it also showed potential as what they call a generative reward model.
Yes.
So, we talked about that reward model that kind of acts like a judge for evaluating the responses.
Yeah, like a writing competition judge.
Well, DeepSeek-V3 can actually serve as that judge itself.
It can, yeah.
So it's not just a talented writer, but it's also a capable critic.
It can evaluate other models.
Which is pretty fascinating.
Yeah, it's really interesting.
Now, before we move on to the final part of our discussion, we're going to talk about, the broader implications of this research.
Yeah.
There was one more detail that really caught my eye.
Yeah, what was that?
And that was this idea of speculative decoding.
Yes.
So can you maybe talk a little bit about how that works?
Yeah, so instead of predicting just one token at a time, the model tries to guess multiple tokens simultaneously.
Okay.
So it's essentially trying to anticipate what those next few words might be.
So it's kind of like reading ahead.
Yeah, in a book almost.
Yeah, that's a great way to put it.
And if it guesses correctly,
right,
it can skip over those usual step-by-step processes.
Exactly. And that speeds things up considerably.
Yeah. And how accurate were these guesses?
Well, the acceptance rate for the second token prediction was between 85% and 90%.
Wow. So really quite accurate.
Yeah, it's very impressive.
And this speed boost.
Right.
I imagine that doesn't come at the cost of quality.
No, it doesn't.
Okay.
They found that DeepSeek-V3 maintained its accuracy and fluency even with this speculative decoding.
So it's still producing high-quality text.
Exactly.
Just much faster.
Right.
Well, I think this is a great segue into the last part of our discussion, where we can really kind of zoom out and look at the big picture and talk about the implications of this research and what DeepSeek-V3 might mean for the future of open source AI.
All right, let's do it.
Okay, so we're back now for the final part of our deep dive into DeepSeek-V3. We've talked about, its impressive architecture, the efficient training, the amazing performance on benchmarks. So now I think it would be good to zoom out a little bit and look at the bigger picture.
Okay.
What are the implications of this research? What does it mean for open source AI going forward?
Yeah, I think one of the most exciting things about DeepSeek-V3 is its potential to really democratize access to cutting-edge AI.
Yeah, I mean, making these tools available
to
researchers, developers, even hobbyists.
Right.
That's a game changer.
Yeah, it really levels the playing field and allows people to contribute to this field who might not have had the resources before.
And we could see a lot more innovation coming from, maybe smaller startups or nonprofit organizations.
Right, exactly.
In fields like healthcare or education.
Yeah, the possibilities are pretty much endless.
And this democratization also, I think, leads to more transparency and accountability.
Absolutely. Because when these models are open source, they can be scrutinized, they can be improved upon.
Right. It's easier to identify maybe potential biases or ethical concerns.
And to address those concerns in a collaborative way.
Yeah, absolutely.
Yeah.
Now, even though the open source nature is a huge advantage, they do point out some limitations.
Yeah.
Specifically related to its deployment.
Right.
Because we talked about its massive size.
Yeah, it's a huge model.
And needing those significant computational resources.
Right. And they recommend larger deployment units.
Right. Which might not be feasible for everyone.
Especially for smaller teams or individuals who might not have the infrastructure.
So there's still some practical barriers.
Yeah, there are definitely challenges, but they do offer some really insightful suggestions for future hardware designs.
Yeah, they talked about dedicated communication hardware and finer-grained quantization.
And these things could really help.
Yeah, potentially making it more accessible to a wider range of users.
Exactly.
Yeah. Now, before we wrap up, I wanted to circle back to this idea of model lineage.
Oh, yeah, that's one of the most fascinating things I think about this research.
Yeah, that DeepSeek-V3 actually incorporates knowledge from its predecessor, DeepSeek-R1.
It's like this idea of AI models passing down knowledge to future generations.
It could potentially lead to a much faster pace of development.
Absolutely.
If models can learn not just from data, but also from the experiences of their predecessors.
It's kind of like this interconnected network of AI models.
Yes, constantly learning and evolving.
Yeah, it's a really exciting vision for the future.
Well, we've reached the end of our deep dive into DeepSeek-V3.
It's been a great discussion.
Yeah, it's been a fascinating journey.
Absolutely.
And we've uncovered so much about this model, its potential.
Yeah.
And I think it really highlights the incredible advancements that are happening in the field of open source AI.
And the possibilities are just going to keep expanding.
Absolutely. Well, thank you so much for joining us today.
Thanks for having me.
And to all of our listeners out there, keep exploring, keep questioning, and keep pushing the boundaries of what's possible with AI.
Absolutely.